Hello, one and all. I am here to present the Charles Law. Myself, Dr. Matkari SS, SMP College, Murum, Taluka Marga District, Usmanabad, Maharashtra. Charles Law. The gaseous expands on heating and contract on cooling. Based on his studies on the variation of the volume of the gas with temperature, Gaseous made the following conclusions. At constant pressure, the volume of any gas expands by the same fraction of its volume at 0 degree. For every 1 degree rise in temperature, according to this law, V1 is equal to V0 1 plus alpha T, where alpha is the expansion per degree. The best value of alpha is 0.0366609 or 1 upon 273.16. Therefore, the equation V1 is equal to V0 into 1 plus alpha t can be written as Vt is equal to V0 1 plus t upon 273 or Vt is equal to V0 into 273 plus T upon 273. The general gas equation. The Boyle's law expresses the variation of volume with pressure, while the Charles law expresses the variation of volume with temperature. That is nothing but Robert Boyle has given his expression related to the volume and pressure. The volume and pressure are inversely proportional to each other, whereas the Charles gives is the relation between the volume and temperature. So one can write the Boyle's law in the form of V is directly proportional to 1 upon P and Charles' law as V is directly proportional to T. That is nothing but as temperature increases, the volume of the gas increases. So this is a directly relationship between the two. The combination of the two, V is directly proportional to T by P. That is nothing but PV is proportional to T. So one can write PV is equal to K into T, where K is the proportionality constant. So one can eliminate this proportionality sign by taking this K as a constant. This equation represents the behavior of an ideal gas with both the temperature and pressure. So this equation may be known as the famous gas equation. Pressure vary and the value of the constant depends upon the mass of the gas and the unit in with the temperature and pressure. If 1 mole of an gas is considered, then one can have PV upon T should be an universal constant. So postulates of the kinetic theory of gases. The theory was first put forth by Robert Hooke and was consequently developed by the Maxwell Boltzmann. Gaseous gives their precise mathematical form in 19th century. The following are the postulates of the theory. First one, the gas consists of a very large number of small particles known as molecules. The molecules of the same gas has the same mass, shape and size. The molecules may differ of different gases with respect, in all respect. The molecules are perfectly elastic in spheres and move constantly in all possible directions. Their motion is chaotic and distorted. That is nothing but they can move anywhere inside the container. The molecule, because of their continuous motion, collide with each other and also on the wall of the container. The increase in the temperature results in the more rigorous movement of the particles, so that if the volume remains constant, the pressure of the gas must increase. The motion of the molecules depends upon the gravity. So the motion of the molecule depending upon their weight and the gravity of the earth. For an ideal gas, the actual volume of the molecule is negligible in comparison with the total volume of the gas. The ideal gas molecule do not exert any force of attraction on one another. That is nothing but there is